Dear students, myself Kasama, and we are here in the class of limits with the help of Al Hospital rule. So, the last class we have already done the limits, and those are the questions on algebra. Today we will do the questions based on trigonometry. Okay, fine. So this is the topic of limits. Okay, now the question is, do these questions, these are some of the questions from trigonometry which you have to solve with the help of the Al Hospital rule, and these are the question of limits. The first question here is, we are going to the first question. In this first question, you see that if you apply the limit x tends to 0 in the denominator, it will give you 0. And when it will give you 0, what will happen? The function will become in an indeterminate form, which will not be helpful for us. So in this very case, when the denominator becomes 0, if we apply the limit in the denominator, then we have to go with the Al Hospital rule. As I have told you in the earlier videos, that if you have to apply the Al Hospital rule, in that rule what you have to do is, you have to differentiate the numerator and the denominator individually. Okay? Now here, if you differentiate the numerator, it will be somewhat like this. First go with the denominator, it is very simple. When you differentiate x, it will give you 1. Now when you differentiate this cot 2x, it will give you minus cosec square 2x. And further, when you differentiate 2x, you will be having 2. Furthermore, you are having cosec 2x. The differentiation of cosec is minus cosec 2x and cot 2x. And when you differentiate 2x, you will be having 2. In this way, you differentiate the cot x as well as cosec x. Let me just tell you once again. The differentiation of cot x is minus cosec square x, and the differentiation of cosec x is minus cosec x cot x. Now, we came to know that when we put x is equals to 0, then the denominator will not be equals to 0. It is an ideal condition for us. Now we can simply apply the limits. When we simply, so here now if we try to apply what we call it as a limit x is equals to 0, then the first thing is, in the denominator we won't be having the 0. First thing is clear. Now the second thing is, but if we put x is equals to 0 in the numerator where there is cosec, and we will be having cosec x is equals to, or cosec 0 is equals to 1 over 0, which means it is equals to not defined, then again there is some problem. So to avoid these types of problems, what we have to do, we have to convert this cosec and cot into the form of sine and cos. What I want to say is that I have to apply this limit x tends to 0, then there is minus 2, there is plus 2, it becomes plus 2. Okay, then I take 2 common and minus 2 common. I will be having in the bracket 1 over sine square 2x. I can convert cosec x into 1 over sine x. Furthermore, this is minus, I have taken common here, this is plus. Okay, now it will become minus because I have taken minus 2 common. Now here it will be sine 2x for the cosec, and for the cot it will be cos 2x over sine 2x. Okay, now what I can do here is, this is limit x tends to 0 minus 2. Here sine square 2x, here this will become sine square 2x. It will come into denominator, and in the numerator you will be having 1 minus cos 2x. Okay. Now this 1 minus cos 2x can be rewritten in the form of a formula which is somewhat like this: minus 2 limit x tends to 0. We know the formula, and the formula is cos 2x is equals to 1 minus 2 sine square x. Okay, this is the formula. So then what it means that yeah, I can write it as 2 sine square x is equals to 1 minus cos 2x. Fine, this is the formula. Now this limit minus 2 limit x tends to 0 will give me 2 sine square x over sine square 2x. This is the right approach. Fine. Now what I have to do is I can rewrite this as minus 2 limit x tends to 0, this 2 sine square x, and here in the denominator I am having the formula for sine 2x, which is equals to 2 sine x cos x. Now here it will become 2 sine x cos x. Okay, it will be equals to, I can take it out, this 2 can go here, this will become minus 4, and this is square here, this is limit x tends to 0, you will be having sine square x, in the denominator you will be having 4 sine square x and cos square x. This 4 will cancel out the 4 here. Now this sine square will cancel out this sine square x, and you will be left with limit minus sign is there, x tends to 0, 1 over cos square x. You will be left with 1 over cos square x. And now if I put x is equals to 0 as in the limit, I will be having minus 1 over cos square 0, and cos square 0 is 1, which will give you the result as minus 1. So in this particular question you will be having the answer as minus 1. Please note it that if you are having cosec x and if you apply the limit here, then we know that cos x 0 is equals to not defined. Then there will be no answer for this particular question. So we have to convert into a specific number. There should be not defined. Okay. So I think the answer is very much clear to you. I will start with the next question. Now we are here on the question number 2. This is limit x tends to 0, and in the numerator you are having 1 minus cos x, square root of cos 2x, and the denominator is x square. Now here, if I apply the limit here and I put x equals to 0 in the denominator part, then I will be having denominator equals to 0. And when the denominator is equals to 0, then the whole function is said to be the indeterminate form. Indeterminate form is the form where you are having the 0 in the denominator, 0 over 0, or any other number in the upper part as well as 0 in the denominator. These are something of no use here in this case of limit. We have to avoid this, and while doing this, avoiding all these things, we have to do some perfect and specific cases. Now here you are having 1 minus cos x square root of cos 2x over x square. We can't directly apply here the limit x tends to 0. Therefore, in this particular case, we have to use the L'Hospital rule. In the case of L'Hospital rule, you know that you have to differentiate the numerator as well as denominator individually. Okay. Now here what happened here in the question is, this is limit x tends to 0. If we differentiate the 1 here, it will give you 0. There is no need to write it. You will be having minus sign. With a minus sign, there are two functions. One is cos x and another one is under root cos 2x. There are two functions. Now, when there are two functions, let they be fx and gx, and we have to differentiate them, you have to apply the product rule. Okay. Now, what the product rule says? The product rule says first you have to differentiate cos x, it will give you minus sin x, and this will remain as it is, cos 2x, and then you will be having a positive sign, cos x will remain as it is, and you have to differentiate the square root of cos 2x, which will give you 1 over under root cos 2x, and then you have to multiply, then you have to differentiate cos 2x, it will give you minus sin 2x, and when you differentiate 2x, it will give you 2. I am writing it here. Okay, this is the whole thing which you are having in the numerator part, and in the denominator you will be having 2x. Now you see that again, if I put x is equals to 0 in individually in the numerator and the denominator, and I will be having the denominator as equals to 0. When it becomes 0, then the whole function will be in the indeterminate form. What this means that it shows that here again I don't have to apply the limit instantly. Firstly, I have to go with the L'Hospital rule. Okay, now I am again applying the L'Hospital rule, and what it means that I have to differentiate the upper part and numerator part individually. But what I can do here is something can be done here or not. Okay, don't think that some things to be done here. Okay. Nothing, I can't see anything is to be done here. Okay, let's move on. Then differentiating the whole thing, but it's going to be too much lengthy while I am thinking about it. Okay, here one thing is there. Here this is not a sine cos x, it is cos 2x here. Okay, because this is 2x. Now what I can do here is I can do the LCM in the numerator part. But first, what I will be having here is this limit x tends to 0, and it will be minus this minus has to be remain outside. But this is minus here, and this minus will come outside. It will give you a positive sign, and everything now is in positive. Now here the LCM is under root cos 2x. Okay, and I can write this 2x with this multiplication in the form of multiplication. Okay, now here in the numerator it will give me sin x, and under root cos 2x when multiplied by under root cos 2x it will give you cos 2x. Furthermore, here this is cos x and this is 2 sin 2x. It will give you 2 sin 2x and cos x. This is the part which I will be having. Okay. Now what else we can do? What else we can do here is we have to do something. Now this is quite a good lengthy question, but here again if I apply the limit here, now I will be having x. If I put x equals to 0 in the denominator, it will give me what denominator is equals to 0. Therefore I have to again apply the what we call as L'Hospital rule, which means differentiating both numerator and the denominator individually. Now if I apply sin x cos 2x here in this part, what I will be having is sin x will give me cos x, and cos 2x will give me what? Cos 2x will remain as it is, plus sin x will remain as it is, and cos 2x will give me minus sin 2x with the 2 in the multiplication and the negative sign here. Okay, plus. Now here in this case, if I do the sin 2x, it will give you 2 cos 2x, okay, and 2 is also there, which will become 4 cos 2x times cos x, plus now if this remains as it is, this will give me 2 sin 2x, okay, and cos x will give me minus sin x, and here this will become a negative sign. Okay, now here this has all done. Now in the denominator part, I am having 2x under root cos 2x. If x is differentiated, it will give you 1. Okay, and now here cos 2x will remain as it is. Plus, now here it will give me 2x, and if I differentiate cos 2x, it will give me 1 over under root cos 2x, and then it will give you minus sin 2x, and there is again a multiplication of 2 also. Okay, now this is the whole thing which is left. Now, if I put x is equals to 0 in the denominator, what I will be having? The single thing I will be having that here if I put x is equal to 0, this whole part will be 0. But this one will be not 0. It means in the denominator I will not be having 0. I will be having 2 as the required answer in the denominator. Understand? I am explaining it again. I am saying that if I apply x is equals to 0 in the denominator part, then this x will become 0, and because of this x becomes 0, this whole lot will become 0. Okay? But if I apply x is equal to 0 here in this case, it will give me cos 0. Cos 0 is equals to 1, and under root of 1 will give me 1. Therefore, the denominator will be 2. This is done when after applying the applying limit. Clear? Now come to the numerator part. In the numerator part, as you know, the value of sine 0 is 0, whereas value of cos 0 is 1. So wherever there is a sine x, this whole term will become 0 and this whole term will become 0. These two will cancel out. Okay? And the remaining is this. This is cos 0 1, cos 2 0, and 0 is 1, this is 1, and here again this is plus 4. This means you will be having 5/2 as the required limit. Okay? By this method you can easily do the questions on the basis of L'Hospital rule. These questions are from the limits and these are the trigonometric questions. Let's do one more question. Let's start with another question. This is limit x tends to 0, 1 minus cos x, cos 2x, cos 3x all over sine square x. Okay, this is the question on a trigonometric question, and you have to solve the limits with the help of L'Hospital. Now, if you put x is equal to 0 and if you go with the denominator part, then it will give you sine square 0, which is equal to 0. This means the denominator becomes 0 when you put x is equal to 0, that is on applying limit. Here in this case, when it is 0, what it shows that you can't solve it, and here in this case you have to apply the L'Hospital rule. What it means, you have to differentiate the numerator and the denominator individually. Now come on to the numerator part. This is limit x tends to 0. Now here the first term is 1, which is a constant term, it will give you 0. I am not writing it about. Now the second term is minus, and after minus there are 3 cos. This is cos x, another is cos 2x, and next one is cos 3x. Then what we know that we have to differentiate it. Now here when we differentiate cos x, it will give you minus sin x, and the other two will remain as it is. This is cos 2x and this is cos 3x plus. In the second part, if we have to differentiate cos 2x, it means cos x and cos 3x will remain as it is. Okay. Now here cos 2x means minus sin 2x, or it will give you minus 2 sin 2x, cos x and cos 3x. And in the third case, we have to differentiate cos 3x. It will give me minus 3 sin 3x, and the cos x and cos 2x will remain as it is. Okay, and in the denominator, you will be having 2 sin 2x, and you are having cos 2x, and if we differentiate 2x, you will be having 2. Okay. This is the required differentiation of the whole topic. Okay, 2 sin 2x and tan 2x will be differentiated cos 2x, and 2x will give you 2. Okay, but again we see that now if we differentiate it, again we are not having the suitable thing. Okay, now if we do something here like this, this will give me a formula, and the formula will be it will give you 2 sin 4x. This is the formula which I will be having. This is 2 sin 4x. Okay. Now if we put, you understand it, if we put x is equal to 0 in the denominator, it will give you 0. And what it means that it will lead to an indeterminate form. Now the next step is I have to differentiate again individually the numerator and the denominator. But now this time it will give you a very lengthy explanation. Okay. Now what we can do here now? I will put them in a different position. Limit x tends to 0. This is the first case. Sin x, cos 2x, and cos 3x. Okay. And I am not converting it into the 2 sin 4x. I am just writing it as this the form is. This is 4 sin 2x and cos 2x. That will cancel out. Okay. Now for the second part, because here the minus sign here, then everything will come into the positive. It will give you limit x tends to 0, 2 sin 2x, cos x, cos 3x, and whole over is 4 sin 2x, cos 2x, and here these two things will cancel out, this will cancel out. Okay, and in the last one is plus limit x tends to 0. This is 3 sin 3x cos x cos 2x, and in the denominator you are having 4 sin 2x cos 2x. This will get cancelled. Okay, now what else we can do here is, now I am doing here in this case. Okay, now here you are having sin 2x. This sin 2x can be rewritten as this is 4, and here it will be sin x, 2 sin x cos x. In this way this sin x will get cancelled by this x. Okay, there is no need to do anything here because here this is cos 2x in the denominator, but here in this case you are having sin 2x, which will give you 2 sin x cos x. Okay, now here this is what? Now this will get cancelled by this. Okay, now if we are able to apply the limits in the first two parts, this part and this part, I will be having here cos 0 will give you 1, and here cos 0 will give you 1. This is 4 2 times 8, this is 1 over 8, plus here this will give you 1, this will give you 1, in the denominator this will give you 1, and 2 will remain as it is. Now here it is equals to 1 over 2. Now the third part I will be having, what I will be having? I will be having limit x tends to 0. This is 3 over 4, I am taking it outside, and here this is sin 3x, and in the denominator you are having this is 1 by 4, this is 8, 3 by 8, and here this is sin x. Okay, here you are having two of these three things. This is sin 3x and this is sin. So here I have to do this sin 3x part. Now here we know that it can be rewritten as 3 by 8 limit x tends to 0. This is sin 3x is equals to 3 sin x minus 4 sin cube x, and whole in the denominator is x. Okay, now we have to solve this. If I do it separately, here this will add up. Now it will give you how much? The LCM will be 8. LCM will be 8, and here this is 1 plus 4. Okay, plus. Now here this will give you 3 over 8. Limit x tends to 0. Oh, this is space, scarcity of space. I can do it somewhere in the denominator. So lower this 3 by 8. Limit x tends to 0. It will give me 3 sin x over sin x. 3 sin x over sin x will cancel out, and furthermore minus 3 over 8, and 4 is there, and there is sin cube x over sin x. This sin x will cancel this cube, and the remaining will be 2 here. Now just wait, I have to rub the upper part. Now here what you are having, this is 5 over 8, 1 plus 4, 4 over 8, plus 3 over 8, and this is times 3. Okay, 3 over 8 times 3, because it will give you 1, multiply by 3, and this is minus 4 and this is 4 to 8, minus 3 over 2, and here this is sin square x. Now here we have to just apply this limit. Now here limit x tends to 0, sin square x. If we put x is equals to 0 here in this particular case, the whole will become 0, because we know sin 0 is equals to 0. Now we are left with these only two parts. This is 5 over 8 plus 9 over 8, which will give you 5 plus 9 is 14 over 8, and this will give you 2, 7, 2, 4. It is 7 by 4. Therefore, you can see that the 7 by 4 is the required answer of this particular question by using the L'Hospital rule to solve this question of limit. We shall do some more questions. Here we are having 2 more questions we have to do. These are on the limits. These are the trigonometric questions. We are doing the trigonometric questions of limits and by using the L'Hospital rule. Okay. Now here in this first part, this is question number 4. Here, if we apply the limit directly here, we will be having x is equals to 0 in the denominator, which means that it is now converted into indeterminate form, which we don't have to do. For this, we have to differentiate this question individually. Now, how we will do this? This is limit x tends to 0 in the denominator part. If we differentiate it, we will be having 1 in the denominator part. But in the numerator part, I will be having like this 1 over under root twice under root 1 plus sin x. And if I further differentiate that part 1 plus sin x, I will be having cos x because 1 is equals to 0. Furthermore, minus in the here again I will be having 1 over 2 under root 1 minus sin x, and in the numerator part I will be having minus cos x. And in the denominator part it is equals to 1. There is no need to write it. Okay. Now what else we can do here? I can take 2 common here, and then after this I will simply do the simplification of this particular question, and I have to take the LCM of the denominator, and it will be somewhat like this 1 minus sin square x, because 1 plus sin x times 1 minus sin x will give me a plus b, a minus b is equals to a square minus b square, which will result in 1 minus sin square x. Now in the numerator part, this will go into the upside. This will give you cos x under root 1 minus sin x, and this is minus minus will give you plus. Here it is cos x, and it will give you what it will give you. It will give you under root 1 plus sin x. Okay, this is quite good. Now I see that if I apply the limits x is equal to 0, and in the denominator I will see that there is 1 minus 0, and it will not give you 0 in the denominator. Therefore what I can do here is I can simply apply the limits in this case. Now 1 over 2 will remain outside. In the denominator you will be having under root 1 minus 0 is 1, and in the upper part you are having cos x, this is 1, and the under root again you will be having 1, and the square root of 1 is simply 1, and here this is 1, and here you are having cos x is 1, and this is 1 plus sin x is again 1, and you will be having 1 plus 1 is 2, and half is coming outside. In the numerator it is 2, and you will be cancelling it, and your answer will be 1. So therefore, if you differentiate it like this, you will be having the 1, and by using the L'Hospital rule, this is the answer of your first part, which is question number 4. This is question number 5th, and here in this case, if you put x equals to 0 in the denominator part, you will be again having the whole of the denominator as 0. What it means that it is then converted into the indeterminate form. Therefore, we don't have to do all these things. We have to just differentiate it for the first time individually, the numerator and the denominator, which is our L'Hospital rule. Now here, what we can write it as limit x tends to 0. In the first part, I have to differentiate x cos x. X is the first function, cos x is the second function. What it means? It means 1 cos x plus x sin x with a negative sign. Therefore, it will become a minus here, and plus sin x will give you plus cos x, and here in the denominator you will be having 2x plus sec square x, since you know the differentiation of tan x is equals to sec square x. Okay. Furthermore, again, if you put sec x is equals to 0, how much sec 0? Sec 0 can be written as 1 over cos 0, and you have the value of cos 0 as 1. It means your answer will be 1 for sec 0. Then what it shows that the denominator won't be 0 anymore. What it means that you can clearly apply applying limits conditions. Now here, if you apply the limits, you will be having cos 0 as 1, minus x is 0, sin x is again 0, therefore it will give you 0, and plus cos x will again give you 1. In the denominator, 2 times x will give you 0, and sec square x will give you 1. What it means that you will be having 2 over 1, which is equals to 2. This is the required answer of this very part. What I want to tell you, students, that these are some of the questions which you will do, and if you practice them very well, you will score very good marks in your IP examinations. Hope very good for you, and I will put some questions in the link here, and furthermore, if you think you need more practice, I can do some more questions on this. Goodbye to you.